We will see this modulation by taking the high frequency wave, and that high frequency wave, from there onwards we will do the modulations. That high frequency wave is called carrier wave. The strength of this carrier wave we can refer as CT, means it is time variable. Equation is AC sine omega t plus phi, omega t plus pi. C is strength of carrier wave. AC is amplitude of carrier wave. Sine is a sine function. Omega is the angular frequency of the carrier wave. Of carrier wave. T is equal to time, phi is equal to phase. So what we can understand with this one, what is angular frequency? Angular frequency formula W is equal to 2 pi nu. Now these are the different modulated waves. This is the carrier wave. This is empty modulated carrier wave. This is amplitude modulation, means see here, shrinking is there, expansion is also there. This one, frequency modulation, means repeated orientations here, and these are the orientations are the with the large gap. You can see that is phase modulation, means exactly the direction will completely change. Maybe it is the top phase which is reversed to the reverse phase also. These are all the different types of modulations. Amplitude modulation, frequency modulation, next one, phase modulation. These are the different types of modulations we can see. So this is the information about, and this is the wave analysis of the modulated waves. Now we will see the amplitude modulation with the help of equation. In amplitude modulation, carrier wave is there, and that wave is modulated, and that wave is called modulated wave, and we are taking sinusoidal wave as the modulating wave or modulated wave. So we can write carrier wave is equal to AC sine omega CT. Modulated wave is equal to AM sine omega MT and to sine omega CT. The resultant overlapping is said to be modulation of amplitude. That's why finally the equation will change like this. AC sine omega CT plus AM sine omega MT into sine omega CT. So we can take common AC sine omega t. We are taking sine omega CT as common. AC sine omega CT as common. Here 1 plus AM by AC into sine omega MT. Now what we can write this equation as AC sine omega CT into 1 plus mu sine omega MT. By comparing these two equations, we can write mu is equal to AM by AC. What is this mu? Index of modulation. So the index of modulation is amplitude of the modulated wave by amplitude of the carrier wave. Amplitude of modulated wave by amplitude of carrier wave. This is the information we can see. Now we will take the solution of these equations by using the trigonometric relations. Good, sir. Now we are going to use the trigonometric relation for the solution of this amplitude modulation. We know that sin A sin B is equal to half of cos A minus B minus of cos A plus B. This is the trigonometric relation. If we use this trigonometric relation to fit the solution, the equation we will get is like this. Modulated wave of carrier wave equation is equal to AC sin omega ct plus mu AC by 2 into cos omega c minus omega m into t plus minus mu AC by 2 into cos omega c plus omega m into t. In this equation, yes, cos A minus B into cos A plus B. This omega c minus omega m is lower side frequency. Omega c plus omega m is upper side frequency. Lower side frequency. This omega c plus omega m is equal to upper side frequency. Now if this is the case, if you added these two, we will get approximately equal to omega c. Means the total frequency is under the carrier wave frequency. The resultant frequency is in the limits of carrier wave frequency. So this is said to be amplitude modulation.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.